Okay, I think we're ready and everything looks like it's ready to go. Last time we did the fusion form tool where we modeled the canopy of the X30, which is not in sight. I don't know where I put it. Well, we did that and we didn't finish the whole thing. We didn't put the little hinge on it and the little latch. And there's one other little band, like a trim piece, that we didn't model that. But we got the form tool in place and made the canopy. So I need to print that out to see if we got it right. I haven't done that yet. That's just, I'm just going to print it in PLA first just to test print it, and then we will go into the resin prints. I did get a roll of filament just because it was interesting looking. This is from, well, let's see. I don't know what brand it is. It doesn't say on it. It's one of the regular brands. I'll have to find the box it came in because the spool. I don't like it when they don't do that, where they don't brand the actual spools. I assume if I could interpret their SKU number, then it would be in there. But anyway, it is metallic champagne. So kind of an interesting color, if nothing else. I bought it on Amazon on Prime Day. Prime Day actually had some decent prices for filament. This one is from, it's Anycubic, and it is a silk filament. Here, I'll show you what its advertisement looks like. Nope, not that. That's what we're doing later. Here. So this is what it looks like in the pictures, and in real life, I'll say it's very similar to that, although it doesn't look quite as dark. It's a little bit lighter in real life. I'll have to print something with it. This particular roll was on sale, but it was still $20. I got another roll of same Anycubic, but a different, not a silk one, just a plain one, and it was like $10. So there are some good deals that you can find out there, and not just on Prime Day. They'll just go on sale occasionally. I did notice, not for, well, this one too, but this one's not as good of a deal, that Amazon on a lot of these filaments have a subscribe option that gets the plain ones, like the matte or whatever. I don't know if any of these are in the plain. I think these are all silk. It gets them down to like under $10 a kilogram, which is a decent price. These are, the silk ones seem to be a little higher, but anyway, I got that. We'll print something with it. We also changed the nozzle on our printer to a 0.8 millimeter nozzle. There's still a couple of things we need to do to make it actually ready to go. We need to make sure that our flow rate is close to right. It's probably going to be a little harder to tune in, dial in, I guess, to tune, than a smaller nozzle like the 0.4 that was originally on there, just because now I've got a relatively large amount of filament that has to be accurately extruded. So we need to make sure our E-steps, I'm pretty sure we already did the E-steps on that. The E-steps themselves should not have changed on the printer by changing the nozzle. The PID tune, it's the same kind of nozzle. I guess it technically has a little less mass to it, but I don't think the PID tune should be an issue, although we may have never PID tuned this printer to begin with, so we might need to do that. And then see if we can get some big layer line prints out of that. Today what we're doing is adjacent to 3D printing. It is going to include, well, you saw a little bit, some metal casting. So this is low temperature metal, like pewter, things like that. And you can melt them in a little hot pot. They melt around, I don't know, not much more than the filament melts at for some of these. Some of them are actually really low, like in the 60 degrees Celsius range. This one is in the 250 Celsius range. So we'll go through what you need to be able to do that, why you might want to do that. If you're interested in creating metal parts, this is a way to do it that doesn't require the next level up of furnace and things like that. Although there are some relatively affordable furnaces that can get you through aluminum casting and some of the precious metal castings if you want to do that. This one is just pewter, and the furnace is just a hot pot. So it is specifically for, actually this one is normally used for things like lead fishing weights and things like that, but it will also work for the low temp metals. Before we get into that, let's talk about our class contest. So part of the assignments are to, you've got the 5 optional assignments, and one of the things that is in there is that you have to enter a contest. So you can just find a contest on Printables or Inventables or Maker World or anywhere on the internet out there that has to do with 3D printing, and you can enter that, and that can be your contest. But if you don't want to do that, or you can't find a good one that you're interested in, then we have a class contest. It counts exactly the same as the ones you find on the internet, but here's the rules for it. So it's in Canvas. Let me show you the picture I'm looking at. So we're going to do a catapult. So I found this, which is a 3D printable cat toy. So it's not very, it's like 10 grams total, so it's not a very big thing. Maybe 1.5 inch diameter. I need to print it out again to show you what the thing looks like. You print this. So you print this however you want to, whatever material. You don't scale it or anything. You just print this, and then you design and build a catapult that's going to launch this thing exactly 10 feet. So without going over. So the launcher is 3D printed, although you can use like rubber bands or springs. You can't use any kind of electric motors, combustion, anything like that. But stored energy like a elastic band, that's fine, or a spring, that's fine. Or you can just have the stored energy be in the catapult print itself, so you could just use the filament as the energy storage. You have to create it by you. You could take inspiration from other ones, but you can't just download a catapult and use that. So don't just print one that you found on the internet, because there are catapults on there. I don't know if any of them are specifically made to work with this cat toy, but there might be. I don't know. So you do that, and then we talked about it. It's not powered anyway, other than some kind of stored energy in a rubber band or a bent piece of filament or a spring, something like that. And then you have to launch the cat toy that you printed, and the idea is that it will land exactly 10 feet without going over. So some of you are able to come to campus, and if you're able to do that, you can August 13th we will, I don't know if we'll meet at 8 a.m. for the on-campus version, probably closer to noon or something, but whenever we want to do that, we'll figure out who is going to come to campus, and you can compete then. But so you'll bring your catapult and your specific cat toy and launch it, whoever's closest to 10 feet without going over. So it is a pressure luck kind of thing. We'll set up rules like you can have 3 launches or something like that. I don't know, and take the best one. But you can come and compete in person. If you're able to compete in person, then we've got some prizes. Like I've got, probably most of the rest of this roll of filament that I just showed you, and things like that we've used in the class. We'll have as some prizes. If you can't come to campus because you're in Wyoming or something, then you can still compete. You just have to video it. Just the only thing there is, obviously, you can edit it as many times as you want until it lands exactly at 10 feet or whatever. So no prizes for that, but you get the glory of you've made it and you've launched it and it landed somewhere near 10 feet. And you still get the credit. So that's the other part. So you can compete remotely without actually having to come here and launch the thing in person. Just there's no prizes other than fame and maybe not fortune for the online ones. All right. So if I see any questions in the chat about the contest or in Discord, or if you email me or come by and ask, then I'll answer them and I'll add them to this section, add the answers to this section here. Should be relatively self-explanatory, but there might be some edge case that I have not thought of. August 13th is the deadline for it, whether you're online or coming in person. If you're online, you got to submit your video. There's a little write up here about what your video needs to include if you're submitting online. All right, and then if you're in person, we probably won't meet at 8 in the morning, but we'll meet sometime on the 13th on campus, and we'll measure out 10 feet, launch them probably 3 times each, and your best attempt is your counting attempt. All right, so on to the casting stuff. So it's really not so straightforward if you have FDM printing to create metal parts. There are filaments that have metal in them, like there's a copper, there's I think there's a stainless steel one, even there's an iron one, and what those are is they're, I don't know, 80% plastic and up to maybe 20% of your metal filament, metal filler. So they do have weight to them, and they do like have a patina that can occur depending on whatever metal's put in there. So they kind of act like a metal piece, but they don't have any of the strength of metal, or in fact they're usually weaker than actual metal parts. But you can get kind of a metal effect that has similar qualities as far as it is heavier than a plastic print, and it does patina and rust and stuff like that if it has a ferrous type of metal in it. But they're not really metal. There's another FDM printable filament that is 80+% metal. It's really hard to deal with. Some of it's even higher than that. Let's see if I can find a, I think it's, oh, I can't remember. Let me look for something real quick. I think it's the virtual foundry. Virtual foundry. It's off the. Let's go to this one. No thanks right now. So this filament. Well, actually, there's some ceramic filaments. These metal filament. There's 14 of them here, and they've got aluminum, copper, high carbon, iron, Inconel, all these different things. So let's just pick the bronze one. So first of all, look, they're expensive. $170 for. This is probably a kilogram, which you have to remember. No, this is half a kilogram. You have to remember, though, that a half a kilogram of mostly bronze filament is nowhere near the same amount of filament that you would have on a kilogram of mostly plastic filament. So this is not the same length. You don't get the same amount because it's still measured by weight, or, well, mass, and it's mostly metal. So it you don't get as much, nearly as much as you would on a just plastic roll. But anyway, this stuff is, let's see if we can find its properties here, 88 to 90% metal. So this stuff is mostly metal and a little bit of plastic binder just to keep it in a filament form. So you can print this. It is difficult to print, and they have a starter kit on how to, on like a pre-warmer, so that it kind of gets a little flexible and it doesn't just snap before it goes into the print head. We've had trouble printing this with heat creep because the metal itself, or the filament itself, is mostly metal and it conducts heat pretty well, and so your hot end, the cool side of your hot end, needs a really good cooling system on it to keep it from experiencing heat creep up into the hot end. But you can print this stuff, and it is mostly metal, but 10% of it's not metal. So what you do after you print this part is you have to anneal it. Well, you have to burn out the plastic and then anneal it, maybe. I don't remember the order. But you have to burn out all the plastic that's in it, so it's going to shrink by about 10%. So you have to plan on the fact that it's going to shrink. So it's either they're showing decorative stuff here like an owl. It's either that you're going to print stuff where the shrinking doesn't actually matter because it's not a functional part, it's just decorative. Here's a Batman. Or you have to take into account the fact that this part is going to shrink down 10%. But once you've got it down, burned out, and you've annealed it into, or no, it's not anneal, sinter. You need to sinter it into a solid block of metal. then it's mostly a solid block of metal. So that means, now I'm looking here and it looks like it says no kiln, but you do need in some kind of heat source that gets up into a kiln level or a furnace level in order to burn out the plastic and to center this stuff together. So you can't just buy a roll of this filament, print it out, and you're going to end up with a bronze owl. And it's not going to be shiny. This one's been post-processed. This one's been some kind of polish on it too, because it does have layer lines and everything that are in any normal print. In fact, you normally print I think a little bit larger nozzle with this stuff too. So let's see if we can find a kit here to see what it would actually take to get started. So here's an evaluation kit. It's got like a few laps of filament and all the stuff you would need, minus the printer. So you got to make sure your printer can actually handle this stuff, and minus any kind of furnace type of stuff. But it's $100, and you get a little set of sintering carbon, sintering ballast, sintering material. So I don't know what they expect you on this one to actually sinter it in. Let's see, because it's not going to be an oven. Look, a kiln has to be programmable controller able to reach 1100 Celsius. So it's assuming you have that somewhere. So at school we have stuff like that, and we can do those things. But here's the real getting started bundle that has more of the actual stuff you would need. There's a little filament warmer to get it a little more flexible before it goes into the hot end. Got more of the sintering ballast and carbon and all of that. A little crucible and a half a kilogram of your material of choice, and we're at $500. You still have to, on top of that, have a printer that can print this stuff, and a kiln furnace of some sort that's programmable, that will slowly ramp up, hold a temperature, and then ramp back down to actually get your part in metal. But you can, if you're dedicated enough and have all the necessary equipment. It's not going to be an oven in your kitchen, but you can print pretty much solid metal stuff with an FDM printer. It's just not a direct, process. There's several steps in between. But the next step for metal parts is, a laser sintering or something like that, where now the machines to do that are $100,000 for the very cheapest one, so this is way cheaper than that. So if you're interested in printing metal, you're going to need that kind of kiln, some kind of it could be electric furnace. It doesn't have to be a gas powered one or anything. It could be an electric furnace, and then a starter kit like this, $500, and a printer that you kind of keep just for this, because it's some of the stuff that we had to do to get ours working makes it where, yes, it would still print filament regularly, but it's probably going to be just this, metal printing stuff. So you're looking at that. Now the printer doesn't have to be fancy. It can be a Ender 3 type of printer. In fact, they sell one, or they did. Let's see if it's still here. Oh, definitely a hardened nozzle. Forgot about that. You definitely need a hardened nozzle for this thing. They actually show a Bamboo Lab hot end. We did not try printing on a bamboo with this stuff. I might try that. Don't know if I want to run it through the bamboo or not, but it does have that as an option here. I don't see the actual printers anymore. It used to be that they sold their own printer, and it was basically a Creality style printer, but I don't see it here anymore. Looks like they've kind of gotten away from that. They've got a tumbler here. The finishing part you can finish however you want to with whatever normal finishing tools you have, like sanding and tumbling or whatever you have. Here's some of the kilns that they have. So there's $2,000 for that kiln, $5,000 for, this is more like a ceramic kiln. I did notice that some of their filaments are ceramics. But we were using more of just a little electric furnace that probably wasn't even as good as this one. So you can do it. So that's another option for getting true metal parts, but it's a difficult one. You got to account for the shrinking and all that kind of stuff, without having to go to all the way to a direct metal laser printer or a laser sintering, type of printer. The other thing you could do is you could outsource it. So maybe you only need this one time or whatever. There are plenty of websites, online fabrication type of shops. Like I usually think of Isometry when I think of that. And these type of sites, you can upload your CAD model, whatever form, they've got all kinds of forms here that you can use, and get a quote for almost any process you can think of. Like if you go to their solutions thing, they've got all sorts of, there's metal, there's direct metal laser sintering, metal binder jetting, all these different metal printing processes where the machines themselves are really out of the reach for most consumers. You're really talking large-ish industries that are going to have these printers. And they got moldings, all kinds of stuff, CNC stuff, and you can get your metal part made that way. The only downside here is that it's going to cost a little bit more because they're making one off of something. We had a project, was it 2 years ago maybe? No, there was one 2 years ago and one last year, this past year, for the capstone, where they needed some metal parts made, and they were not simple parts to just go turn on a lathe or something like that, and so they used some of these CNC options. And the first one, if you just get one of them, yes, it's kind of ridiculously expensive, but even places like this do provide economy of scale type services where, hey, if you order 500 of these or 100 of these, there's different breakpoints for it starts to get more reasonable. So you can do some small scale manufacturing with sites like this, but it's still going to cost more than if you have it in-house somehow. Other than the fact that you had to buy some very expensive machine to get it there. So you could do that. The other thing you can do is what we're going to do today, and that is you can print your part, and we're gonna do one of these. So this is Lord of the Rings, the little elf brooch that the Fellowship gets when they get their cloaks, and we're going to make one. We're not going to do the green part. The green part, some kind of resin inlay. We could take some of the resin, the liquid clear resin that I got. I think I showed it the other day. It's right here. We can get some of this stuff, pour it into the cavities of this brooch, tint it green, because it's supposed to be green. Tint it green, and then you can cure even this kind of resin. This resin is it cures with UV, and so you can take like a UV flashlight, which you can get off of Amazon or I don't know if you can get them at Walmart and places like that, but you can get UV flashlight at Amazon for sure. Let's see, and they're not expensive, like $15 maybe. Yeah, one of these got $12 to $8, something like that. You can get one of these. In fact, we did some resin printing intro a couple of days ago. If you were going to do resin printing, I would get one of these. Apparently I got this one purchased in 2020 because it helps you clean up any spills, because you can cure them on the spot and just peel them up, the resin. Or you can make repairs to your print. Maybe it does have a crack in it. You can put in some of the uncured resin straight from the bottle and then cure it with this, and it cures in like 10 seconds with one of these flashlights. So all that to say, we could pour in resin tinted green and cure it with one of those flashlights, and we could actually make this part. Maybe I'll do that offline depending on how well our cast comes out. So that's our goal. So what I did is I went to, I think I did the Maker World site, the bamboo one, and somebody had this as a pattern. So I've got it over here, and it's just this guy. So I printed this. I just printed it. Oh, I can't pick it up. I just printed it laying flat, which means it doesn't have as much detail. Also, it looks like this pattern, they were using it for metal casting, exactly like what we're going to do. But it doesn't look like this pattern has been really designed for optimum metal casting. Because what we're going to do is we're going to do a sand cast. So I've got some sand back here. It's not just regular sand. You can use kind of a regular-ish sand, but there's generally two big categories. There's a green sand, which is pretty cheap. You can actually even make green sand. It's clay and water and maybe another binder type of thing. This is Petrobond, this stuff, and it is a sand that has an oil, petrochemical in it. What you're trying to do with either of those is create a sand that is, malleable, but it'll hold its shape whenever you press it, because the sand, actually you probably shouldn't mess with that stuff. That stuff does have oil in it, so it'll leave your hands kind of sticky. I've got some gloves over here. But this is gonna be our pattern. We're gonna press the sand all around this and then remove this and pour molten, in this case pewter, into your cavity left by this pattern. So this pattern needs to come out of our little mold easily. Our little flask that I made is just a 3D printed flask. But I do have a metal one. You can get metal ones. This is more if you were doing a two-part mold. We're just going to do an open pour just for simplicity's sake today, where we're just going to have the cavity sitting out on top and pour the metal into it. Here's one I did last time. So the downside to open pour is like the back face is not very smooth. It's bubbly, like the surface tension of the metal causes it to bubble up, and you don't always get the right thickness. So this was our pattern for this one, just a printed, this was FDM printed, and this is what we actually got. So this is a solid chunk of metal, of pewter, and it works, just like metal. You can kind of see there's some mishaps here and down there, but actually those are in the print. So we're over here. I don't know how well you can pick up that the print itself had problems there, and I just didn't bother to fix it. The better your pattern is, the better the cavity in your sand mold is going to be, and the better your final product's going to be. You can even see that I picked up the layer lines. I think you can see those. The layer lines themselves picked up out of here. With these sands, the green sand is cheaper. It's easier to deal with. It's not. It doesn't give you quite as good of a surface finish, surface detail rather. So it may not pick up, which might be good. It may not pick up the little layer lines in your print. The Petrobond style is going to hold detail better than the green sand will, but it costs a little more. But both of them are generally pretty reusable. Like I've had this stuff. The one I have came in a little, I don't know, it's a 5-pound bag from Delft Clay. I don't even know if they're still a thing or not. But actually I got it from Auto Freight or Free, I don't know. But they're a jewelry company, or well, they sell things that are related to jewelry production, and sand casting is one of those things. But that clay has been good for years, for years and years. But I don't do this very often. Let's see, what else? Oh, you need some kind of metal. So I just have a block of pewter that I use. You do have to be careful with the low temperature metals. So most low temperature metals are going to contain some lead, or there'll be lead, and you probably don't want to play around, because then you need some ventilation, some respirators, or you need all that kind of stuff to deal with lead. And there are, unless you just really need a metal that has lead in it, there are metals that don't have lead in it. Pewter, the old pewter, like if you went to an estate sale or something and got some pewter pieces there and thought, oh, I'll just melt these down. I wouldn't do that, but thought that's what you would do. Maybe you had a broken piece. That older pewter does have lead in it, but the newer pewters don't. So you're kind of trying to avoid any of the low temp stuff that has lead in general, unless you want to have a more elaborate setup and deal with the fact that you have lead, which is not good to handle and breathe. I guess you can touch it fine, but the fumes and things like that you don't want to deal with. But you can get metals, new pewter, new formulations of pewter, stuff like that, that don't have any lead. They're usually tin, mostly tin, and then maybe some bismuth is in there usually, and maybe antimony might be the other thing that's in there. I can't remember what the other thing usually is that's in there, but most of it's tin. So that's what we have here. I want to do the low temp stuff because if I do anything starting like in the aluminums and higher, this is not going to melt it. This little guy is called the Hot Pot 2, and there's several iterations of it on Amazon. Let's see if I think I linked them in Canvas, but let's see if I can find. What we're looking at here. This little guy, $80 or so, and it's literally just a heater with a cast iron cup plugged into the wall. That's all there is to it. There's no temperature control. There's no on off other than unplugging it. But it works for these low temperature metals. There are other types of these. I'm seeing a lot of cooking ones, but maybe if I click on one of these, then it'll show some of the similar items. Well, you can get some tools that go with it if you want to make some ingots or whatever. There's some of that Delft clay right there. This is a different distributor or brand on it, but this is a good casting material. Some of the true Petrobond stuff, the oil in it, if you just leave it unattended for lengthy periods of time, it will go rancid, and so it'll not be something you want to work with. But this stuff, I've had it for years and years, and it has not had that problem. But you know, now you've got another $20-something there. You don't have to get this stuff. What I'm using is a baking sheet and a spoon that I found somewhere, and one of these little scrapers that came with one of the printers. As long as you're using steel type of things, then they're going to be fine. They're not going to melt anywhere near where this pewter is going to melt. I have a little tamping rod to pack down our sand in here, and I do have the sand. I did buy that. Printed a little flask, open-sided flask here, although I did buy one if we ever wanted to do double-sided stuff. And that's kind of it. You need a release agent of some sort. So you want your pattern, where I don't even know what year it is, you want your pattern to easily come out of the sand that you've packed around it. And normally what I use is just cornstarch, like you would use in cooking to thicken something up. It's a really good release agent, but I didn't have any today, so I used an actual release agent that you spray on. I'm not sure how well it's going to work because it's really meant for other materials instead of plastic, but I think it'll be okay. But you want something that makes this come out of your sand without destroying the sand mold. Also, like I was saying, I never finished my thought on this pattern. I was saying that this pattern doesn't look like it's specifically made for casting because all of the edges on it are vertical. They're all straight up and down, which will make a good indention. But when I go to pull this out of the sand, it would be a lot better if there was a draft angle on all of these vertical edges. Instead of being vertical, they were tilted 3 to 5 degrees or something. And that would make them release out of the sand a lot easier, particularly when it's printed and there are layer lines that want to grab a hold of the sand. So it's very possible that a lot of these inside pieces are going to pull sand out of our mold with it, and we won't get that detail. We're just going to go with it and see what happens. So the process is we need there is some metal still in there. I'm going to put that guy in there and turn it on by plugging it in. get all of our other stuff out away from. Oh, the other tool I have is a soft paintbrush. So this usually takes in the, I don't know, maybe 10-minute range or something to melt. We'll let it do its thing here. And over here, I'm just gonna I'm gonna put on some gloves because this stuff, it's not dangerous necessarily. It's just that it does get your hands all oily if you mess with it. So I've got some gloves where you won't have to worry with that. There's way more metal in here than we'll need, but that's okay. So so normally I would have put some of the cornstarch on here and kind of dusted it around, but like I said, I sprayed on a release agent. And you might even want to like super glue your pattern down to this thing so it's going to come out easier, but I think we'll be okay. So we're just going to drop in some of this stuff and press it down in there. The better you get your sand into all the little features that you want to capture, the better your end result is going to be. May have to get a little bit more of this, I don't know. And you use your little, whatever you're going to use to pack it in there. You can reuse the sand. The parts that actually touch the metal probably are going to be a little scorched, and you may have to throw those parts out, but most of the sand, like all this back here, is fine to reuse. The one thing I don't like about that hot pot style is that there's no real indicator that it's on. Like there's no light, there's no nothing, so you can't forget that that's going to get to 750 degrees or so. Now that metal in there will melt. 750 Fahrenheit is somewhere around 400 Celsius, and that metal will melt in the 200 something, 250, somewhere in that range Celsius. So it may not get all the way up to 700 if we don't just let it sit there. So I don't want to spend inordinate amounts of time, but the better you make your little mold here, the better your final result will be. And I'm not making this particularly well. Looks like there's a little hole there that this is going to be the bottom, so I'm not too worried about it, but I do want it to be flat. Alright, so more or less like that. And then we turn everything over. There, alright, so I can already see that, you know, there's a little bit of gap that didn't get filled in because I kind of just dumped the sand. You know, I didn't really take up a lot of time trying to get sand around everything. So we're not going to get all of our details, but that's not going to be the end of the world. A hard part is you got to get this pattern out of here without destroying the impression it made. So a lot of times what you'll do is you will add some holes in here that you can put a screw in and pull it out. I did not do that. Oh, well, actually, I didn't make this pattern. I just got this pattern off of the internet. Checking on our metal. So if we tap around on this. Maybe it'll loosen up a little bit. Get something heavier than that. I do have some sticky tack that I want to try and stick to it and see if we can get it out of there. It's slowly coming out. This edge is not wanting to release. Now the bottom's not wanting to release. Oh, look, our metal, that's just kind of what it does. It's like, once it melts, it's just all melted. See if I can get some of my sticky tack down here and pull this bottom part up. Got some more sticky tack. Let's get some more. I don't want to get the sticky tack in the sand. Oh, all right. So, we didn't get it all out. See, it's caught up in there, caught up in there. So those parts won't actually make. In our metal, there are probably impurities in here. You can kind of see the discoloration. You can just take and scoop out anything that, like the dross. Alright, that's going to be good enough for what we're doing. And now this is just an open mold. And so we're just going to pour it in, and I'm going to try not to overfill it, but it's kind of hard to control. And you can kind of see how it wants to overflow. You know, it's got a lot of surface tension. So that's kind of the way these open ones would do. And there's not a whole lot that you can do other than create a two-sided mold where it's not open on the back. Those are just harder to create. But what you would do if you wanted to do a two-sided mold is you would do this, what we just did, not pour the metal in. And then these are, they're two halves. And so you pack the other half into the same process, and then you take them apart, pull your pattern out. Then you have to cut in some kind of runners for the metal to get in there. So you just manually go in and cut some, grooves. You might have to have some air vents for if there's air in here and you want to put metal in. That air has to go somewhere, so you have to put some kind of exhaust vents in there, and you just cut them in. This stuff dries pretty fast, or not dries, cools down, solidifies. It's still hot, but it's solid, and so then you just take it apart. And there's what we got. So we already knew we were going to get we were going to have some problems because our pattern didn't get some of these details in here. We could have done better with our release agent. So the stuff that I used kind of worked. A lot of these patterns came out in here just fine. Let's see if we can get closer. A lot of these came out fine, but the ones up here where it was trapped between two pieces, those didn't come out. So better release agent. Some draft angles on our pattern itself, so that it's sticky, so that it didn't want to catch this filament, or not filament, sand in there. And just being a little more, we did this one really fast just so it doesn't take forever on a live stream. But we did get this, and it looks decently good. It has problems, but we picked up the layer lines even again. Not layer lines, the top finish. You can actually see where the top layer is. We did get some of this little vein. I don't know if that's what they're called in leaves or not, but we did get that. We got the general shape. In there needs to be cut out. In there needs to be cut out. In there. If we wanted to deal with the backside being kind of bulbous, we could sand all that down. And it's metal now. It's still hot though, so I don't want to pick it up. It does cool relatively fast, but it will stay hot for a while. I also turned our hot pot off, although it will stay hot for a while too. So you have to be aware that you've got things that they don't look like they're hot, but they are just sitting around. So you have to be careful of that. But reasonably, comparatively cheap compared to other ways that you can get metal parts from a 3D print. And the more care, like this one is a more ideal pattern. Where are we at? It's simple, it's not a very complicated design, and even it doesn't have enough draft angle. It has some, but the print itself needs to be cleaned up. And you don't just have to print it and press it into the sand. You can print the part and then, or the pattern, and then do a lot of effort cleaning up, sanding the part, priming it, putting coatings on it or whatever to make the pattern better when it comes to releasing, coating detail and still releasing from the mold that you're trying to make. Let's see if this is warm, but it's not like blazing hot. We'll put it on here. So that's what we got. That's what we got. Definite problems in there because of the way the pattern was made, and the fact that we didn't spend a whole bunch of time trying to get the mold in the sand to look good. The good thing is, you don't like this one, you put it back in the pot and make a new mold, make a new pattern if you want to, and do it all again until you get it the way you want it. Because the last time we saw this piece, it was a Star Trek communicator, and now it's a elven brooch of some sort. All right, so this is all kind of warm right now, so I'm going to let it cool down, and I think that's probably enough for today. We'll be back on Friday. I think we'll go back to the X30 probably on Friday, or maybe we will do some of our finishing techniques. So what kind of materials, say you've got a plastic printed part and you want to finish it and you want to do something to paint it or to make it look like metal but it not actually be metal. There's stuff we can do to make the actual finish on the post-processing side of a plastic print. So maybe that's what we'll do on Friday if I can round up all this stuff. Anyway, we'll be back on Friday. Check out the rules for the contest if you want to enter our class contest. And if you have any questions about those, let me know.